All right, fifth graders. So this is the back page of lesson 19 problem set. I'm going to go over each one of these. I already have it written out. I would encourage you to try and get as much of this as possible down on your own and then kind of use it to check or pause the video at any point if you find that you don't have some of these things down. Okay, so first thing, list all the properties shared by all the squares that you worked with today. I know that squares have 4 sides that are equal in length. The second characteristic, I know they have 4 90-degree or right angles. The third characteristic, I know that their opposite sides are parallel. And the fourth characteristic is that the diagonals are perpendicular bisectors. So what that means is if we take our square and we are going to draw that diagonal line, okay? From corner to corner. Gonna draw that diagonal line from corner to corner. I see where those diagonals meet, where they intersect, they form a perpendicular line, right? So they're coming together at a 90-degree angle. That's what we mean by that, okay? Moving right along. List the properties shared by all of the kites we worked with today. I see that kites have 4 sides. They have 2 sets of adjacent sides that are equal in length. So if I look to the front, I have 1 set of adjacent sides. Okay, adjacent means next to each other, A and B, that are the same length. And then another set of adjacent sides, C and D, that are also the same length. They have at least 1 set of opposite angles that are equal in measure. So when we look back to our kite here, we have 1 set of opposite angles. This angle here between A and C and B and D, okay? Both of those are 100 degrees, okay? So they have at least 1 of those sets that are equal in measure. And then so diagonals cross at right angles. One of the diagonals bisects the others. So what we could see here, if we were to draw a diagonal, okay, is that we would draw our first diagonal from point to point, okay, and then we would draw our second diagonal across from point to point. Okay, we see that one of them is going to cross the other and that they're crossing at that 90-degree angle. All right, moving right along to see, when can a rhombus be called a square? So I know that a rhombus is a parallelogram with 4 equal sides. It has opposite equal acute angles and opposite equal obtuse angles. Okay, a rhombus can be called a square though when it has at least 4 right angles, okay? When it has at least 4 right angles. Okay, next one, moving on. When can a kite be called a square? A kite can be called a square when it has 4 sides of equal length and 4 right angles. So remember that rhombus already has 4 equal sides. A kite does not have to have 4 equal sides. So when it has 4 equal sides and also those 4 right angles, it's also going to be our handy dandy square, okay? And we can see that reflected in answer C right here. All right, our last one, when can a trapezoid be called a kite? A trapezoid can also be called a kite when it has at least 2 pairs of equal adjacent sides. So what that means is we have our kite here, A and B are the same length, lines A and B are the same length, and then C and D are also the same length. So 5th graders, that's all the geometry for today. Like I said, please feel free to pause the video at any point and be sure you're getting all this down. It's a lot. Once again, we don't expect you to necessarily have a ruler or a protractor for you to measure these angles. You can do your best with estimation, or you can just kind of copy down what I have on my paper onto your paper, all right? So I hope you enjoyed your daily dose of geometry, and I will let you get to it.